The topic for today is tips and tricks for SQL query management, specifically within our products, kind of like InfoWorks ICM, Info Asset Manager, and just kind of all the different ways to use SQL queries within those tools. So again, our host kind of today for this Water Talks are myself, Tim Medeiros. I've been a solution engineer and I've been with Envise for about 4.5 years now. I'm calling in from just north of Denver, Colorado. Yeah, super excited to be with Nathan here presenting this topic. Nathan, do you want to go ahead and introduce yourself?
Yeah, I'm also solutions engineer, 5.5 years with Innovise. I've worked a bit with ICM, and just over the years, I've always found and kind of snagged and gathered various examples of SQL queries because I found it hard to find good training, but whenever I'd find good examples I could learn from, I've just been growing this library, and it's been a fun side project, and so I've been wanting to share them with in a Water Talk type form. So looking forward to getting into the content today.
Nathan for the main bulk of today's presentation.
All right. Yeah. SQL, it's just so pervasive as the language for interacting with data. So if you are building your career off of interacting with data of any type, it's definitely a worthwhile language to get familiar with. I mean, even GIS uses SQL queries quite a bit. So for today, we're talking about SQL in the InfoWorks platform. There's many dialects of SQL. Unfortunately, SQL Server syntax is going to look a little bit different than in InfoWorks. There's pros and cons. So we're going to cover lots of examples to get you equipped to be able to write your own queries. And what are the things you can do with SQL? Well, you can, and this is just some of my library that I've been accumulating over time. So SQL can be used to select stuff. You can really hone in exactly on what your selection, what selection you want to use. You can generate tables. This is one of the core uses in many other database platforms. It's basically just generating a view of data from your database. So you can generate tables, you can edit data, and you can create and delete objects. So there's really a lot you can do with it. There's not a lot of huge limitations. You can't import data. That's something you could do with Ruby scripts, which could maybe be a future topic of a Water Talk. But for now, we're just going to be manipulating data that's already in the database. All right, so jumping into selections. This is kind of what the UI looks like. There's various buttons you can use if you want to. We're not going to really cover the UI as much in this Water Talk. I'm going to mostly just dive into the language because the UI is really just to help you write the language. It is important what object type you choose, and this field drop-down list is always very useful. But many of these other things, it's really just what you type is what it's going to do. So that's what I'm going to focus on. So if you just type conduit width greater than 24 for our North America or US users, then it's going to select pipes that have a pipe diameter of greater than 24 inches. You can accomplish the same thing by saying select where conduit width greater than 24. And I'm not sure what happened to my underscore, but that should be there. So so that the full the explicit expression, you'd say select where some kind of clause. If you leave that out, ICM is going to know what you're trying to do. So some different commands are select where. You could deselect. You could select selected. So if you already have one selection, then you want to sub-select from that. You can select selected. You can also select from if you want to select from other object types, and you can clear selection. So with these, you can combine these to really hone in on exactly what you want your selection to be. And you can also do multiple lines. You always have to have a semicolon if you're doing multiple lines. So here we're going to say clear selection, and then we select where conduit width is greater than 24. So we're going to replace our selection just with these larger pipes. And we can also further further isolate it using and or statements. So we say, and the solution model is full. So these are your gravity mains with a large diameter. And you'll notice we're typing and it doesn't really say anywhere that we're selecting from pipes. That's accomplished with this drop down where we say object type all links. You can do that with the code itself. So you could also with your code select pipes and nodes and valves, whatever else you want to accomplish all in one script. So to do that, you say select from and all nodes where chamber area is less than 12. So these are like maybe any nodes that are, a little bit too small of a size or something like that. So you can select from multiple tables. If you leave this out, it's going to assume you're selecting from this dropdown up there. And you can also do text matching. So you could say select where your asset ID matches, and then you could enter any kind of text. So my 2-year-old likes pandas right now, so I just said panda. And if you do wildcards with a dot star, this is going to find any asset ID that has panda anywhere within the asset ID, either with 0 or many characters before or after it. So you can find much more details in the help file on the syntax. We don't have time, obviously, to go into the syntax of everything. We're just kind of covering some of the capabilities. And also, SQL is case insensitive in ICM. So it really doesn't care if you use caps or not. I like to stick with a convention because it makes it easier for me to understand it down the road. So I stick with all caps for any generic SQL commands like select, from, where, update, etc. But for the actual field names, I leave it as lowercase just because that's how it comes populated in ICM. So you can choose a format. And actually, since this is my first slide or first content, I forgot I should mention, I prepared a file share that has the PowerPoints in PDF format and a SQL query script. So all of the queries that I'm showing in this presentation and all of the examples that I'm going to show in ICM later, you can download them from that file share. And we can see if we can break our file share with having all of the attendees download at the same time. But so you can follow along with any of these. I didn't give like models to test it with, but there's a handful of examples, so you can follow along if you want. All right, and another useful thing is generating tables. So maybe you want to analyze your database and pull out certain records that match cases. So we covered select where conduit width greater than 24. That will create an object selection. But if we insert one or more fields, like say select conduit length where conduit width greater than 24, so long as there's a field in there, instead of selecting objects, it's going to create a table for you that just pops up within the UI. You can review it, you can sort it, you can copy and paste it to Excel. And that's going to just give you all of your links for your large diameter pipes. And you could comma separate to get multiple columns of data. You can also say order by the conduit width, ascending or descending. So you can get tables like that. If you're doing this on a regular basis, maybe you want better column headers. So you can say select OID as pipe ID. And then now you're going to get pipe ID as the header. And maybe if you're doing this on a regular basis, you also maybe want to use comma and just return to the next line. So you can have multiple lines so that, that makes it just easier to organize your script. And if you have to comment out or remove columns or add columns, you can easily do that when it's all arranged like this. And you can also use a group by function. So you could say select sum on the conduit length, and then we group by the width. So what this does is it adds up all of the pipe length grouped by different diameters. So this is an example of that table. So for 30, this is all my 30-inch diameter pipe, and that totals 29,000 feet. And so that's useful. But what if we want to do a table like this, but we want to group it by a field that is more continuous, such as surcharge, or something where it doesn't fit into easy bins? What if we want to define our own bins? You can do that using the R-index function. I hadn't used this much myself, but it's definitely useful. And so this is the syntax. You'd say, you create a list, and we'll come back to lists later, but you say list, and you can define your list from 0.3 up to 2 for surcharge state. And then we're going to say select the count. So we're just going to count the number of pipes in each bin. And then we just use title R-index, the surcharge results, and then those bins. And that's going to come up with a table. So you can see that all of your pipes with a surcharge value of 1, so they're full, there's 33 of them, but 3 of them are full, and the current flow exceeds the theoretical flow from Manning's equation. So these would be pipes that are actually hindering the flow upstream. And you'll notice this sim got highlighted in pink. That happens in ICM when you have a subtable that's joined. So this is one of the powerful things of SQL, is that you can join different tables as you're querying out data. And in most databases like SQL Server, this actually requires a bit of code to do inner joins, where you have to join things together. Within all of the InfoWorks databases, the nice thing is that these tables are already pre-joined for you. So if you have results, you can then just query those, the flow, the velocity on those pipe diameter, with your actual pipe data. And so there's joined tables, and this is really common, especially with asset data.